Alrighty, so welcome back, everybody. We're looking at the 2-6 worksheet K. Call it worksheet K because you see it's form K over in the top right-hand corner. Okay, so basically what this is just a lot of the same things you guys did on the other 2-6 worksheet. Some of it's a little bit harder, some of it's a little bit easier. So I think the best thing to do is just dive in. So 1, 2, and 3, and I know there's no 3 on there, but we can just put it right there. We are asked to find the value of the variables. Now, number 1 has just one variable, x. Number 2 and number 3 have x and y. So what we need to do is we need to identify the relationship between the labeled angles, then set up an equation to express this relationship, and then go from there. So, first things first, we're going to look at number 1, and we see that they are vertical angles, okay? So we know from the vertical angle theorem that vertical angles are congruent. Sorry about that pause, I dropped my stylus. I do have a stylus today, so my writing should be neater. Please understand it will never be neat, but with a stylus it is neater. So we know vertical angles are congruent, so we can set up an equation expressing that relationship of 68 minus x is equal to 3x. From there, we're going to add x to both sides, so we get 68 equals 4x. Divide both sides by 4, and we get x equals 17. Okay, so x equals 17, so that's the answer to number 1. Moving on to number 2. So we're going to start off now, 2 and 3 we're going to have to run twice. So the first time we're going to say that those two are vertical, and that's going to allow us to find the value of angle x. Not angle x, the variable x. So we go 10x minus 18 equals 8x plus 14. Again, even though they're top and bottom now, they are still bow tie angles, which means they're vertical angles, which means that they are congruent, which means that I am spending too much time coloring this in, but I'm being kind of OCD and having to get it actually done. Yay, there we go. So if you turn it sideways, which I just did on my screen, but you guys can't see it, it looks like a really poorly done bow tie. Okay. So we're then going to subtract 8x from both sides. We get 2x minus 18 equals 14. I'm going to add 18 to both sides. So we get 2x equals 32 divided by 2, and we get x equals 16. So we know that x equals 16. So now I'm going to quick erase all that. Now we can use that x to find the value of y. We know that those two angles, 10x minus 18 and x, are supplementary. We know this because they're a linear pair. They form a line. We know a linear angle is 180 degrees. So we can set up that 10x minus 18 plus y equals 180. We know that x equals 16, so we plug it in right there. So we go 10 times 16 minus 18 plus y equals 180. So 160 minus 18 plus y equals 180. 142 plus y equals 180. Subtract 142 from both sides, and we get y equals 38. And what I'd like you to do is I'd like you to try number 3 by yourself. Number 3 is almost identical to number 2, just different numbers. So it's much more like an algebra problem than the geometry problems you've been running into. So why don't you go ahead, hit pause here, work out number 3 by yourself, come back, check your answers. Okay, you're back. Now if you just played through, that's really weird because this has been like 2 seconds since I said to pause it and work on yourself. But we end up with x equals 50 and y equals 20. Okay. So now we're going to look at exercise at 4, 5, and 6. Now notice what 4, 5, and 6 do, or they refer us back to 1, 2, and 3. Remember, there's a 3 right there. So what we're going to do is we are going to solve for each of the values in each problem, okay? So let's get rid of those. Oh, yeah, just go back. Don't worry about it. Okay. So we remember from problem number 1 that x equals 17. We need to find the measure of the labeled angles here. Right there. So we're going to plug 17 in for x. We got 68 minus 17. We get 51. We want to double check that we did our math right. So we go 3 times 17 equals 51. Now, if we're super confident here, feeling a little cocky, what we can do is we can just say, hey, listen, they're vertical angles. Therefore, they are congruent. I personally like to go ahead and check just to make sure. It's a great way to check. It's one of the things I love about math. So you can almost always make sure you have a right or reasonable answer. If you solve for a variable, you can go back in and you can plug it in. And if your answer makes sense, you're good to go. If you end up with something like 4 equals 72, probably want to go back and check your work. Moving on. So the answer, that's the answer for all of them. The answer for number 4 then is 51 and 51. For number 2, remember we had 2 different variables, x equals 16, y equals 38. So there are 2 different ways we can do this. We can kind of refer back to when we did problem 2, realize that 10x minus 18 and y, that these angles right here are a linear pair, which means they're supplementary, which means they add up to 180. So I can go 180 minus 38 and get 142 and say, okay, well then the top and bottom angle are 142. Now we also double check that by plugging x in. So we go 10 times 16 minus 18. That gives us 160 minus 18, or 142. So there are 2 142 angles there, so we're going to put 1 down for each. For number 3, and x equals 50, and y equals 20. So again, we can just plug the 20 in there and go, well, if that's 20, then the other one's 180 minus 20, or 160. Or we can plug the 50 in. 3 times 50 plus 10 gives us 150 plus 10, or 160. Notice if we did the plug the 50 in down below, we'd get the same thing. 4 times 50 is 200. 200 minus 40 is 160. So that's what 4, 5, and 6 are going to look like. And that brings us to number 7, a proof. Yay, everybody cheer. Okay, why is nobody cheering? Everybody cheer. Okay, it's a proof, no one's going to cheer. Anyway, notice here that they give us all the statements, so we have to fill in all the reasons. Now again, going back to what we talked about yesterday, the reasons are the why of this situation. Okay? The reasons say why we can do this. Without those reasons, we're just sitting there and giving statements. A lot of people ask, why do we have to do proofs? When will I ever have to do this? Something along those lines. And here's the thing, guys. Will you ever have to do a mathematical proof again in your life after you get out of geometry? Unless you're going into hard sciences or like a math degree, and as several of you just rolled your eyes, that's okay. The answer is no. You're never going to have to do a mathematical proof again. That being said, what doing proofs teaches you is solid deductive reasoning. And what that means is it's a way to build an argument. It's a way to justify your reasons. And that skill will be invaluable to you. Being able to sit there and justify every step you take, every action you take with a solid reason instead of saying, oh, because I wanted to. Oh, I was bored, so I did this. Oh, I thought it was a good idea at the time. Oh, it looked fun when Mikey did it. Hopefully there are no Mikeys in the classroom, and if so, I apologize. But you know what I'm saying? That saying, I did this because A, B, C, you're going to be able to sit there and have better discussions. You're going to be able to think through problems better. If someone ever asks you why you did something or challenges an idea, you'll be able to form better arguments in support of what you did. And that is the most important thing. So I tell a lot of my kids, proofs are hands down the hardest thing we're going to do in geometry, but it is also probably the most important thing we're going to do in geometry. Because if you can learn to do a proof, if you can learn that level of deductive reasoning necessary to work through a proof, then everything else gets so much easier. And not just in geometry, but across the board. Because then you're able to use that deductive reasoning to really break it down, a problem, into its individual parts. As Marcus Aurelius said, ask of each part, what is its purpose? What does it mean by itself? And then build your argument from them. See, not only did you get a math lesson today, you got a quote from Marcus Aurelius. How great is that? Okay, anyway. So let's break this down. So we have angle 1 is congruent to angle 2, and that's a given. So now we need to look at step 2. We need to look at angle 1 plus angle 2 plus angle 3. That's not at all what it says. It says the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5 equals 180 degrees. So we have those three angles right there, and together they equal 180 degrees. So why can we say that? Why can we say that those three angles are 180 degrees? Hit pause, take a minute, talk about it with the person sitting next to you. In my class, I call them study buddies. So that's what I'm going to call them in your class too. Talk to your study buddy and come up with a reason why 1 plus 3 plus 5 must equal 180 degrees. So again, through the modern marvels of technology, no time has passed here at the Renard household, and yet several minutes have passed while you guys discuss this intimately. Okay, so the most common answer my class gave was supplementary. Well, there's supplementary angles because they all add up to 180. It's a great idea. It's a great start, but here's the thing. If we were to look at the definition of supplementary angles, we would see that it starts off with this statement, a pair of angles. So I want to stop there and go, hey, listen, this is an issue. We don't have a pair of angles here. We have three angles. We have 1 plus 3 plus 5 equals 180. Okay, and since we don't have a pair of angles, we can't say they're supplementary. What we can say is that we took that 180 degree angle, this one right here, and we broke it up into three little parts. When we add those three little parts back together, we need to get back to where the whole is. Think about it this way. If I went into a bank and exchanged a 20 for 4 5s, if I add up the value of the 4 $5 bills, I still get the value of that $20 bill that I gave them. Okay? And the reason we get to do that is called the angle addition postulate. You guys should remember that from chapter 1. Okay, so that's the angle addition postulate. So now we need to sit there and we need to look at step 2 to step 3. What changed? What's different from step 2 and step 3? We can look at that and we can see, hey, what changed? And it's that we replace the measure of angle 5 with 90. Okay, so looking up here, we see that the measure of angle 5 is indeed 90 degrees. It's got that little right angle symbol on it. Now, I don't like this proof for a couple reasons. One, not just because it's a proof, but it kind of skimps out on things. It takes shortcuts. Legitimately, there should be another step in there stating that the measure of angle 5 equals 90 degrees. Because only once we say that the measure of angle 5 equals 90 degrees, and that would be the definition of a right angle, would we then be able to substitute 90 degrees in for 5. I think the makers of this were already up to 8 steps. Legitimately, this proof should probably have 12 to 15 steps, depending on how you break it down. And they just thought that was too many and that, kids would be overwhelmed. So, anyway, I think the most straightforward here is substitution, because we're switching out that 90-degree angles for the measure of angle 5. But I think it can also be the definition of right angles. Definition of right angles is that 90 is that all right angles are 90 degrees. So, now, what changes between 3 and 4? Well, that 90 disappears. That 90 disappears, right? So, it doesn't just disappear. We can't just erase it out of existence, wish it gone, poof. Rather, we need to move it away. So what we end up doing is we end up subtracting 90 from both sides. And you guys should remember from your bell work, the property that allows you to sit there and subtract the same amount from both sides is the, wow, that got out of hand really quickly, subtraction property of equality. And again, I put POE for property of equality. That's not actually a thing. That's just my shorthand because I guess I'm lazier than the average mathematician. And I don't like to write, and I don't want to subject my students to any more of my writing than they absolutely have to. So, now we're looking from 4 to 5. Now, when we look from 4 to 5, we see it as a completely different set of numbers. So we go from 1 plus 3 equals 90, and then step 5 is 4 plus 2 equals the measure of angle 5. Well, here we have just a different set of numbers, so what we really want to do is we want to look back to the diagram, or back to the drawing, rather. So we look up there and we go, how are 5 and 4 and 2 related? And again, I have a little bit of an issue with this. This really should be broken down into several different steps. But what they're getting at is that 4 and 2 together make an angle which is vertical to angle 5. So we want to use the vertical angle theorem. But frankly, technically, you'd also want to sit there and say the angle addition postulate as well. So we're just going to stick with the vertical angle theorem. There you go. So now we can see from 5 to 6. Again, we're switching out 5 with 90. Now on this one, since we've already had the discussion about whether or not 5 is a right angle, we can just write substitution. Okay. So now we're going to look at it from 6 to 7. Now what happens between 6 and 7 is the measure of angle 2 gets replaced with the measure of angle 1. And that we're allowed to do because of right here, that first statement. That's given. So we switch out one thing for another. That's called substitution. So as I just circled and then erased, when we're looking here, let me clear this up a little bit. What we're really doing to get number 8 is we're combining 4 and 7. And again, this really should be broken down into several different steps. Because what's really going on here is we're saying that because 1 plus 3 equals 90 and 4 plus 1 equals 90, that 1 plus 3 equals 4 plus 1. And that would be the transitive property of equality. Okay? And then we would subtract the measure of angle 1 from both sides, and then we'd get the measure of angle 3 equals the measure of angle 4. So what's really happening here is we're kind of using both the transitive property of equality and the subtraction property of equality. They just combine that into one step, which you normally don't see, but again, I think that the people are just trying to sit there and not overwhelm students by giving them a 15-step proof. Okay, so hopefully that made sense. Broke it down step by step. You really want to sit there when you're looking at a proof. You want to sit there and try and justify every step you're taking. Almost like you're trying to teach it to someone else. You don't want to just say, this is what I did. Someone says why, and go, well, that's how it works. You want to be able to sit there and actually justify it. Okay, moving on. Number 8. So here it says that A and B are adjacent complementary angles. C is supplementary to the angle formed by A and B. What can you conclude about C? So what I want to do here is maybe draw a picture. So I'm going to draw this picture here, and I know that A and B are adjacent complementary angles. And that means that together they form a 90-degree angle. So I can sit there and go A and B. I then know that C is supplementary to the angle formed by A and B. That means that A plus B plus C equals 180 degrees. Since this is 90 right here, this has got to be 92. So we can conclude that C is a right angle. Okay? And again, we can do that because we know the measure of A plus B equals 90 degrees. We then know that 90 plus C equals 180. We can subtract 90 from both sides and we get the measure of angle C equals 90. Since a right angle has 90 degrees, and a 90-degree angle is a right angle, we can just sit there and say angle C is a right angle. Okay, number 9, this is a little paragraph proof. Kind of quick and dirty. What we're going to do is we basically only use 2 things here. So 1 is congruent to 4 because it is given. Okay, that means that 1 right here and 4 right here are congruent. We need to prove that 2 and 3 are congruent. So first we're going to start off and say that 1 and 2 are congruent. So we look at that relationship and we go, hey, those are vertical angles. And we know that vertical angles are congruent by the vertical angle theorem. Okay? So we sit there and then we look at 2 and 4. Well, I know that 1 is congruent to 4 and that 1 is congruent to 2. So I know that if 2 angles are congruent to the same third angle, they must be congruent to each other. We went over this again yesterday. Think about it like this. If 6 plus 6 is 12 and 4 times 3 is 12, then 6 plus 6 equals 4 times 3. Same general idea here. Because 1 is congruent to 4 and 2 is congruent to 1, then we can kind of get rid of the middleman and say that 4 is congruent to 2, and that is the transitive property of congruence. Okay. So then we look at 3 and 4. So 3 is congruent to 4. And again, we're going to kind of double dip on the whole vertical angle theorem. Okay. So now we're down to our last step. And as we went over yesterday, our last step should always be what we're trying to prove. Here, we're trying to prove angle 2 is congruent to angle 3. And why is that? Well, here we have two is congruent to 4. 3 is also congruent to 4. So that means that 2 is congruent to 3. And that again is the transitive property of congruence. So again, we were able to do this proof by only using the vertical angle theorem and the transitive property of congruence. Now there's nothing that says we can't do that. There's nothing that says that we can only use each theorem once in a proof. A lot of proofs, you're kind of doing the same thing over and over. So, especially things like substitution, transitive property, we use those all the times, and very frequently we use them more than once in a single proof. Okay, moving on, we're at number 10 now. Okay, so 10, these are vertical angles. Okay, so the first thing we have to do is set them equal to each other, and we're going to solve for x. And we get x equals 2. Now, we're then going to have to use that 2 to figure out the measure of each labeled angle. I'm not sure where angle went, but, it's gone. We'll let it go. let it be. And we'll just go ahead and solve for the angles. So we're going to plug 2 in there. 5 times 2 is 10. 10 plus 8 is 18. I like to check my work, so I'm going to go plug the 2 in down there. 10 times 2 is 20. 20 minus 2 is also 18. They check out. It makes sense. They have congruent vertical angles, so time to move on to number 11. Number 11, we have 3 angles here. What I want to do is I want to use 2 of them to solve for the value of x, and then I can plug x in and use that to solve the remaining angles. So 9x plus 2 equals 10x minus 12. We're going to subtract 9x from both sides. We get 2 equals x minus 12. Add 12 to both sides, and we get x equals 14. Okay, so now what we have to do is we have to plug 14 in there. We get 10 times 14 minus 12. It's going to give us 140 minus 12, or 128. I can double check that if I wanted to, but I'm going to trust myself. So I go up there as 128. Now there are 2 different ways to find out that third one. I can either go 180 minus 128, because again, if we look back at what we did before, those are linear pairs, which means they're supplementary, which means they add up to 180 degrees. So if one of those angles is 128, the other one's got to be 52. We can double check that by going 3 times 14 plus 10. It's going to give us 42 plus 10, or 52. That checks, so we know that our work is correct. Moving on, number 12. So we need to name 2 pair of congruent angles in each figure. So what we want to do is we want to sit there and go, okay, congruent means they have the same measure, and we need to justify our answer. So, in the first one, we have vertical angles. Okay, we can either go top, bottom, or left, right. So, being that we need 2 pairs, well, we should probably do both of them. So we're going to angle WQY is congruent to WZQX. Just so you guys know, those are these angles right here. And then we also have WQZ, that's this angle right here, is congruent to double angle YQX. And that's this angle right here. So those are the 2 different sets. Those are the only 2 congruent angle pairs. Now over on number 13, we have a few more options. Again, we need 2 pairs of congruent angles. So we can start off with those 2. Those are what we'd say is that AGC is congruent to EHD, and we would say that is true by markings. Okay, so by markings, we know that that's true. Oops, blue pen. We know that that's true basically because the picture says so. And when a picture tells you something, you do what the picture says. Don't ever listen to pictures. They're tricky, they lie, they just want your soul. So anyway, moving on. We're going to go AGC is also congruent to HGB. Those are those 2 angles right there. And that's true because they are vertical angles. Right there. We also have, and I'm not going to write these down. I already got 2 down, but I'm going to show you other possibilities. AGH is congruent to CGB. Again, vertical angles. EHG is congruent to FHD, vertical angles. EHD congruent to GHF, vertical angles. As a matter of fact, all the black angles would be congruent either by being vertical angles or by being congruent to each other, because 1 and 4 are congruent. That means 2 and 3 are also congruent. And then we could also say that any of the red angles, 5, 6, 7, 8, are also congruent. Okay, moving on. So, last 4 here. Now these are tough. Okay, so what I want to do here is I want to just try and break this down and make it look as much like an algebra problem as possible. Now, each one of these, except for 16, and we'll get to that when we hit it, is a system of equations problem, okay? So what I want to do is I want to let the measure of angle A equal x, and the measure of angle B equal y. And hopefully by changing it from angle A and angle B, and instead talking about x's and y's, it's going to be a little bit more comfortable for you guys. Now here's the thing. The rules don't change. We could do this just as easily. We'd get the same answers. We'd take the same steps if we were using the measure of angle A and the measure of angle B. But the reason that I suggest substituting out for x's and y's is that you guys are more familiar with it. You see those x's and y's together, you kind of know what to do. See those measure of angle A's, measure of angle B's, and your heart skips a beat. You're like, oh, I can't do this. This is too hard. When in fact, it's the same exact problem. Don't let that fool you. Okay? Math doesn't change just because we start using different symbols, just because we start using different letters, just because all of that stuff, it gets harder, but we're still using the same basic procedures that you guys used back in 4th grade. Addition, multiplication, division, and subtraction. Okay. So let's turn this sentence, angle A is 3 times as large as its complement B, angle B, into a set of equations. So first we know that they are complementary. What does that mean? Hopefully someone said they add up to 90 degrees. I'm not that omniscient, so they add up to 90 degrees. So you can write it out. X plus y equals 90 degrees. So that's our x, angle A, our y is angle B. So now we need to turn that A is 3 times as large as B into a sentence. So A is, that's x, equals 3 times as large as B. So x equals 3y. So now, right here, we have our kind of basic system of equations. X plus y equals 90, and x equals 3y. You guys dealt with this a lot back in algebra. You guys should be all pros at this. So what we're going to do is we're going to take that 3y, plug it in for the x. So this would be solving by substitution. We go 3y plus y equals 90 degrees, or 4y equals 90 degrees. We divide both sides by 4, and we get the lovely number 22.5. Now we take that y, plug it back into one of the other tubes. Now, hopefully if we did this right, doesn't matter which one we plug it into, we're still going to get the same answer. So we get x plus 22.5 equals 90. We subtract 22.5, and we get x equals, it's actually 78.5. I'll end up fixing it later, but, or not, it's actually 67.5. I'll end up fixing it in a second. So here we have x 3 times 22.5. So we solved for it the first time by plugging in x or y there, and then the second time we did it by plugging in y there. Now if we did it, we should get 67.5 in both spots, and when we run the numbers, we do. And since we have 67.5 as our x, we know that our y is 22.5. We can sit there and be comfortable that that's our answer. So let's move on to number 15. Should be able to move a little bit quicker now that we're kind of used to it. We're going to start off with, again, let measure of angle A equals x, measure of angle B equals y. These two are supplements. That means that x plus y is going to equal 180. Okay, supplementary angles, 2 angles which add up to 180 degrees. There we go. Now we know that x is A, y is B. So x is 21 less than. That means that whatever x is equal to is going to have a negative 21 on that back end. Now keep in mind, a lot of people, when they see 21 less than, their instinct is to write 21 and then less than, so 21 minus. But if I said, what number is 4 less than 10? You'd say 6, hopefully. Because 6 is 4 less than 10. So in writing that out, I would write that as what number is 4 less than 10? I'd go x equals 10 minus 4. But if the other way around, I'd end up with negative 6. So when you see that less than thing, it says 21 less than something else. That negative 21 is going to go on the back end. And then on the front end, we have twice as large, so that's 2 times y. So that's our second equation, x equals 2y minus 21. And just like in number 14, we're going to do some substitution. So that gives us 2y minus 21 in place of the x plus y. That y is just, well, in place of the y, equals 180 degrees. Combine like terms or simplify. We get 3y minus 21 equals 180. We're going to use the addition property of equality to add 21 to both sides, and we get 3y equals 201. They're going to divide both sides by 3, and we get y equals 67. So again, I should be able to plug that 67 up into either one. I'm only going to do one of them this time, but trust me, it actually does work out both ways. You can do it if you want to, just to check. So we have x plus 67 equals 180. We're going to subtract 67 from both sides, and we get x equals 113. Okay? So the measure of angle A equals 113, that's our x. And the measure of angle B, that's our y, equals 67 degrees. So those are the only two angles which make those two statements true. Okay, now let's look at number 16. A is congruent to its supplement B. Now we could write out x plus y equals 180, then x equals y, and then go through all that. Or we could look at this and go, hey, I remember in the book we went over something called the congruent supplement theorem. So in the book, I think it's like Theorem 2.8 or something like that. And it says that if two angles are supplementary and congruent, then they are both right angles. Here we have two angles which are congruent and supplementary. So we have two right angles. Measure of angle A equals 90 degrees. Measure of angle B equals 90 degrees. And here we are on the final one. Yay! Okay. A is 18 more than 5 times its complement B. So again, let's start off by saying A equals X, B equals Y. They are complementary, okay? So the X plus Y equals 90. We just went through, so we have down at the bottom there, angle A is 18 more than 5 times its complement B. So x is 5y plus 18. Again, substitution. We're going to take that 5y plus 18. We're going to plug it in for x. And we get 5y plus 18 plus y equals 90. Combine like terms, 6y plus 18 equals 90. Subtract the 18 from both sides. And we get 6y equals 72. That's not right. It's 62. No, it is 72. I was right the first time. So y equals 12. We know y equals 12. We plug it back in. And we get x equals 78. Now notice that's true even if we did it the other way. 5 times 12 is 60. 60 plus 18 is 78. So there we go. I hope this was informative. I hope you guys learned something. I've got a ton of videos on this YouTube channel, so if there's anything that you guys are unsure of that you went over with Mr. Bustos, feel free to go back, watch any of those. And, you know, if you want to subscribe, I post these videos throughout the year. You can help, you know, increase my subscribership as I aim to take down PewDiePie. That's a joke. But really, if anything I can do to help you guys out, let me know. I'm in room 202B. I have no social life, so I spend all my lunches in there. So if you ever want to just drop by and get some help with anything, let me know. Thank you very much. Have a wonderful afternoon, and I will See you guys on the next video.